Hi there! On the repair bench today is a vintage WAVETEK Model 278 12 MHz programmable synthesized function generator that shows an error message in one of its modes. The vacuum fluorescent display is still very nice and bright. The wavy flicker effect is caused by the camera shutter capturing the multiplex display and not visible when looking at it directly. The user interface is pretty strange, but after a while it makes sense. The keys are all foil type and some need a bit of pressure to register, but they still work. Probably one of these days the keyboard could do with some cleaning, but that's not why we're here today. The stat key, short for status, cycles through the current setting in a loop until you press stat again. You may wonder that it says sine and 5-volt amplitude when the scope only shows a blue rectangle function. The blue rectangle is actually the signal on the sync output, which is always present. The actual function output is still turned off, which is the default after power up. The generator has a built-in test called the quality assurance procedure, which runs through the major functions and is probably used by the factory. To run it, you use the RCL, short for recall, 2000 exec. You can also write your own procedures or settings and store, recall and delete them. At step 0 of the QA procedure, we have a signal on the yellow trace and the generator waits for a cursor up before proceeding. Cursor up advances to step 1 of the QA procedure, which continuously sweeps the frequency from 1 kHz to 10 kHz. Step 2 changes the function to triangle and continuously modifies the amplitude by exercising each bit of the amplitude setting. Step 3 changes the function to rectangle and continuously exercises each bit of the DC offset setting. Step 4, and we are back to a sine curve, now set to 5 kHz or a period of 200 microseconds. The internal trigger is set to a pulse width of 100 microseconds and the trigger output to the scope is set to be delayed by 50 microseconds. When triggered, the generator starts one complete period of the function, in this case sine, and since the trigger ends before the cycle is finished, only one period is shown. The generator always outputs complete periods, not something like a half sine or triangle. Step 5 is testing the gate operation with a burst count of 6 periods. Step 6 is testing just burst by changing the burst count continuously from 9 down to 2 and then restarting at 9. The fairly simple any rising edge scope trigger means it has some trouble in showing the bursts in a nice and stable way. They either overlap each other at higher horizontal speeds or the scope gets confused which sync pulse it should use for its trigger. And that's the end of the QA procedure. Everything works as it should. What about the error then? To demonstrate that, I exit the QA procedure using RST or reset, which sets everything back to defaults. Now I need to set the output back on to see a wave on the scope. By default, the generator frequency is selected by a microprocessor, switching appropriate range capacitors and within a range a processor generated voltage, because the generator is voltage controlled. This method is used in continuous mode, triggered, gated and burst. The fourth mode is synthesized, and if I execute mode change to 4, I get an error, loop not locked. The synthesized modes for 4 and above do not work. Moreover, the QA procedure only checks modes 0 to 3, so it might have been so for a while. Looking up the message in the service manual brought me to this section. So plenty of components that may have gone wrong and could have caused this. I removed the screws holding the bottom plate and slid it out. This reveals the power supply and the processor, as well as the battery keeping the RAM to store your own procedures and settings. The problem is probably not here. Doing the same on the upper cover plate, and this looks more like it. In fact, there are two large PCBs taking nearly the whole area of the unit on top of each other. Looking down at the rear, you can just see the underside of a third board, but that is the power supply processor board we saw earlier. It turns out nearly all the chips mentioned in the service manual troubleshooting guide are on the topmost board, which is very convenient. I tested around the components mentioned, but did not see anything amiss. Here is, for example, the 3.2 kHz reference signal that plays an important role, and there's nothing wrong here. Here is a very simplified diagram of the PLL, or phase locked loop. Basically, the PLL compares the frequency generated by the function generator with the one from the synthesizer. This generates a control voltage that adjusts the function generator's voltage-controlled oscillator so the frequencies match. This correction is done continuously in a loop. As a result, the frequency produced by the function generator becomes as accurate as the reference input to the synthesizer, which is normally a 10 MHz crystal, but you can also use an external input. In this day and age, we are used to function generators that are super accurate. This generator dates from a time when this wasn't so easy. In non-synthesized modes, the frequency is accurate only within a few percent, but in return you can go down to 10 mHz and you get non-continuous functions like trigger, gated and burst modes you have seen. In synthesized mode, the function generator produces very accurate frequencies, but they have to be 10 Hz and above and continuous, so no bursts and the like. The service manual is very comprehensive and just shy of 150 pages, not an easy read. While working my way through the functional description, I occasionally looked at other sections just for a change, so to say, one of which was calibration. I'm always interested to see how this is done and what inputs and equipment is needed. This part caught my eye, probably because it stands out in the otherwise empty remarks section and because of the problem with the PLL, which drives a voltage-controlled generator, VCG. Basically, modes 0 to 3 stuff is calibrated in steps 1 to 28 and the synthesizer from step 29 onwards, but there is this mysterious jumper that has to be moved first into E9 and E10 position and later back to E10 and 11. Might be worth checking that jumper, which is on the board below the top one, which I have so far not really looked at. I marked the jumper position with a red circle on the PCB layout. I also notice there are practically all trim pots for calibration on here, about 30 of them, so there has to be a way of accessing this while the generator is running. Indeed, all that's needed is removing 2 screws. And then the top board can be hinged up while everything is still connected. That is a neat solution. Even better would be a way of locking it in the hinged up position, but a screwdriver will do as well. And what do you know, that jumper is still in the position for calibrating the generator without synthesizer by connecting E9 with E10, when it should be in the position connecting E10 with 11 for operation or cal of the generator with the synthesizer. I have never come across this type of jumper where the pins are part of the jumper and the board contains sockets. It is obviously designed so it will never fall out by itself because it's stuck pretty good. Inserting it in the right place is tricky because my hand blocks the light and I can't really see where the sockets are. A torch solves that problem. Apologies for the strobing caused by the torch. Once it's loosely in the right place, I can push it in, which takes quite some force. Let's see if that fixed the problem. Note that the generator is set to 1 kHz, but the frequency on the scope is a bit off. Partly this is because it's still warming up after I just turned it on, and partly because it's running in non-precision mode 0. Switching the mode from 0 to 4, which is with synthesizer, and yes, it now works, and the frequency moved a lot closer to 1 kHz because the PLL is now controlling the generator to match the crystal-controlled synthesizer. The whole thing is still warming up, and in a few minutes it will be more stable and accurate. This was the only thing wrong with this generator. Everything else was working and it meets its specs reasonably well. I can only assume that whoever did the previous cal never completed it. That way they forgot to move the jumper back to the position needed for operation in synthesized mode. If you like my videos, don't forget to like and subscribe and help growing this channel, and consider becoming a Patreon. The link's in the description. Thanks for watching.